So today we're going to talk about graphing, as you might have gathered from your preview exercises. We're going to do some things by hand. We're also going to do some things using graphing utilities like graphing calculators and GeoGebra. And then things that are coming up, your project, your first project that's about graphing and uses GeoGebra is due Friday. And then after that, the following week, Monday, I'll give you your first take-home quiz, and it'll be due Wednesday, the 10th. All right, so people seemed very comfortable with the preview exercises, so I'm just going to jump right to the teaching demo. Okay, so finding the x and y intercepts of a graph. The x-intercepts of a graph are the places where the graph crosses or intercepts the x-axis. Similarly, the y-intercepts are places where the graph crosses the y-axis. Okay. So to write the coordinates of the x and y-intercepts from our preview exercise, y equals 4 minus x squared, where did that graph cross the x-axis? -2 and -2. And those are x coordinates, right? What are the y coordinates of those points where it crosses the x-axis? 0, yeah. So 2, 0, and -2, 0. And then what about the y-intercept? Where does that graph cross the y-axis? 4 is the y coordinate, yep, and the x coordinate is 0, 0, 4. Good. All right, let's think about how we would find these algebraically. So you plotted a bunch of points and drew the graph, which allows you to just look at the picture and determine where the x and y intercepts are. But if you didn't have a picture, we could do it algebraically. In general, to find x-intercepts, picture a point on the x-axis, right? It's got coordinates something we don't know, right? To get to that point, you go some distance to the right or to the left. And then what's the y coordinate? 0, right? And that's a y coordinate of 0. So if you want to find an x-intercept, the thing you know is that y is 0. So you start with your equation, y equals 4 minus x squared, and make the y a 0. And then you solve for the x, because that's the thing you're looking for, the x coordinate. So to solve this, I have a couple of different options. I could factor that, or I could get the x squared by itself and square root both sides. Let's do both. Let's do both ways. Method 1. 0 equals 4 minus x squared. How does that factor? It's the difference of two squares. 2 minus x times 2 plus x. Difference of perfect squares. Yep. And then when you have two quantities multiplied together and the answer is 0, one or both of them have to be 0, right? At least one of them is 0. So either 2 minus x is 0, or 2 plus x is 0. And then you solve both of these and you get x equals 2 or -2. And that's what we came up with just by graphing. So in general, to find x-intercepts, make y 0. And solve. Okay. To find a y-intercept algebraically, picture a point on the y-axis. We're looking for some point on the y-axis. Its coordinates, it's the y coordinate we don't know, but we know its x coordinate is 0. So to find the y-intercept, you make x 0. So we do 4 minus 0 squared, which is 4. So in general, to find y-intercepts algebraically, make x equal to 0 and solve. All right, so it's just a very brief introduction to x and y intercepts using algebra. by hand. But we're going to do a little bit of introduction to the graphing utilities that we'll be using in this course. We're going to talk about how to use a graphing calculator and then also how to use GeoGebra. So can you raise your hand if you happen to have your own graphing calculator with you? 1, 2, 3. Okay. You can use the one on your phone if you know how to use it. If you don't, I have a bunch of graphing calculators to lend so you can follow along. So I've got a projected version of the calculator. The one I'm projecting here is a slightly older version, so some things that pop up on your screen might look a teeny bit different, but you'll be able to figure it out. Okay, so first thing I want to do is I want to graph the equation 4 minus x squared using the graphing calculator. You already graphed it by hand. You know what it looks like, right? It's a parabola that opens down. We know where its x and y intercepts are. So I'm just going to have the calculator generate this graph for me. It's going to do the exact same thing you did. It just plots a bunch of points and connects them with a curve. Okay, so you turn the calculator on. Lower left button is the on button. And then you press y equals, it's the upper left. And if there's anything there, you just press clear. So all the way on the right, like 2/3 up. And you're going to type in the equation 4 minus x squared. So 4 minus, you got to be careful to use the blue minus button and not this negative sign. Your TI differentiates for some reason between a subtraction sign and a negative sign. Okay, so 4 minus x. X is the button next to alpha that says xt theta n. If you press that, it should give you an x. And for square, you can either use the little squared button that is on the left-hand column 5 up from the bottom, or you can use this little caret that's right above the division sign. That little caret you can use for any exponent. So that means raised to the, and then you put a 2. So x to the 2. So we press the y equals button, we entered the equation into y1, and then all you have to do is press graph. It's the upper right button. So you may or may not have a good picture at this point after you've pressed graph. Okay. I'm going to pause here. Okay, so we have to choose a window or a viewing rectangle. It's an important consideration when looking at the graph. Okay, so the coordinate plane, the xy axes, is infinitely large, right? There's the origin where they meet, and then the x-axis goes forever left and right. The y-axis goes forever up and down. It's infinitely large. You can't fit the whole thing on this little tiny screen. So you have to tell the calculator where on that giant plane you want to look. Okay, so the way you choose that is you go to the window button, and we're going to change xmin, xmax, ymin, and ymax. Leave xscale and yscale and xres alone. You don't change anything except xmin, xmax, ymin, ymax. So a standard viewing window that you might typically start with would be -10 to 10 for x, -10 to 10 for y. So for xmin, xmax, you type -10, 10. Skip xscale, we typically leave that at 1. And then ymin, ymax, -10, enter, 10, enter, leave the scale at 1 again. Yes? Oh yeah, then you can change it to 1. Yeah. All right, so once you have your window adjusted to be -10 to 10 for x and y, press graph again, and you'll get a nice picture of the parabola. There's a shortcut for getting that standard window, the -10 to 10, -10 to 10. If you press zoom 6, zoom is the middle of the top row. Option 6 is Z standard for zoom standard. That's the -10 to 10, -10 to 10. So it'll automatically pick that for you. All right. Anybody still having any kind of issue with their graphing calculator? Want me to come look? Okay. Okay. Next graphing utility I'm going to show you is GeoGebra. It's a free downloadable software. We're going to use it frequently in and out of class. If we use it in class, it'll typically be just me showing you something. I'm just going to project it and you can see. For outside of class, you're going to use it for almost all of the projects over the semester if you're doing test light and counting projects. Okay. So to get GeoGebra, you just go to geogebra.org, and if you're going to download it, you just click downloads. I would recommend downloading a full desktop or laptop version, whether it's for Windows or for Mac. The download for an app, right, for your phone or for a tablet, it works, but it's not as user-friendly as the full version. So I would recommend the full version if you have access to a computer. So yeah, just click download, just download the version you want, and then what you end up with is a program that looks like this. Opening it now. All right, so here's my GeoGebra, and I'm going to graph. I'm going to use GeoGebra to graph the equation 4 minus x squared. So in the input bar is where you type equations. The input bar is down at the bottom. And so I'm going to type y equals 4 minus x caret, just like on the graphing calculator, use a little caret for exponent. It's to shift 6 and then square it and hit enter. And you get a nice immediate graph. And then on your graphing calculator, to adjust what the window looks like, you had to use this window button and manually change everything. In GeoGebra, you can use this little move graphics view, click it, and then you can move this thing to center it. Okay. You just click and drag to move it around. And then if you want to change the scales, you just hover your mouse over one of the axes, click and hold it down, and then you can drag, right, to change the scales on the axes. So I'll do like, that looks good. And then change the scale on the y-axis. You just hover until the mouse changes, click and drag. Yes. So I'm just scrolling with the little scrolly thing on the mouse to zoom in and zoom out. Yes. Yep. Good. See, what else am I going to do here? So that's all I'm going to show you with GeoGebra right now. You're going to learn lots more on how to work GeoGebra in Project 1, which I want to suggest that everybody do, even if you're not planning on doing projects this semester because you're going to go with the test heavy option. Everybody should do Project 1 for 2 reasons. It's the only project that's due before the first test. So if the first test doesn't go as well as you thought it was going to go, you'll have that project done, so then you can go, well, all right, maybe I'll do test light and that test won't hurt me so much. And also, it's a really great introduction to GeoGebra, which is a really useful tool in any math or science class that you take in the future. So, what? Yep. Yep. All right, so I'm going to let you jump into the activities here, where you're going to play around with some graphing. Keep the graphing calculators I handed out. Some things are going to ask you to use those. And then if you get to the end, the very last thing is to start work on Project 1. And you can answer all the questions, the technical part of it, creating the graph in GeoGebra, you have the graph, so you can answer all the questions about it before you actually jump into GeoGebra and figure out how to use it.